Hello everyone. So this is the third video that I'm posting in Flying with Physics. So this is a quite a common problem, I would say. Common problem in the sense the theory is quite common. This is actually when you release a particle, a charged particle within a electric field and magnetic field, how it will behave. So in this problem, what is happening? There is an infinite wire, as you can see. This infinite wire contains a charge lambda, charge per unit length lambda, and there are three this is a system which is a three-dimensional system, and as you can see there is the r coordinate, then theta is a polar, angular coordinate, and then h is a down, basically z coordinate. So that's how the whole system is. Now what is happening, at a distance now, around this infinite wire there are two cylinders. One is at a distance r0, which is imaginary cylinder, I would say, and another is actually a cylinder at r1. So a particle of charge mass m and charge q is released at this point O, which is at a distance r0 from the central wire, infinite wire. And what is happens, this particle initially automatically travels towards r, because there is a lambda, and that will cause a Gaussian surface, and from that Gaussian surface it will move towards that r. But as soon as it gains velocity, the magnetic field, which is upwards, as you can see, will have an influence, and it will deflect that particular charge towards through an angle theta, as you can see here. Now not only that, because of its weight or mass, it will also come down. So it will have a kind of curved path, three-dimensional curved path, through which it will traverse, and then finally at some point in time it will hit the outer cylinder at point P. So the point is, at what time it will hit that point P is one of the solution of this problem. Now if I see here, the point P where it hits, if we can assume that it is hit at the time interval of t dash after the charge is released, then this t dash is actually should be defined by this infinite series solution, logarithmic solution, as you can see, wherein r1 is the final radius, r0 is the initial radius from where the charge is released, and this t1 will basically satisfy this particular equation. Now this is one part. Secondly, how much it will actually shift angularly, that is also another thing to be calculated because of the magnetic field. Now this angular displacement can be defined by this second order differential equation, as you can see here. This also has to be proved, and this should have a boundary condition between r0 to r1. But accordingly, if we solve this, the theta, the distance by which it is moves by angularly, will also kind of we get that. And similarly, by that time t dash, it will also come down because of gravity, and it will finally travel at, this will be simple because this gravity is constant, and all these forces are actually mutually perpendicular to each other, so they will not have an influence to one particular component. So ultimately, due to gravity, it will come down by h, as you can see, and that will also be defined by this. So ultimately, this P point will satisfy a coordinate considering these three things. One is of course r, based on r how much it shifts, that is angle theta. So from that you get the r theta, the arc length by which it actually moves, basically r1 theta, and similarly the h will give the exact position of that point P where the charge hits the outer cylinder. Okay, so this is a problem. I would say that I have already posted like 2-3 problems out here. This seems to be a simpler one among them, but then again, we need to have all different kind of varieties into our solution and into our ways of handling problems. The only thing that you might see a bit tricky here is basically forming this differential equation, because by default the shift of that theta will depend on time. Okay, whereas this particular equation I have changed it to kind of dependent on the distance r, because if I keep on time, there would be a slightly problem. Ultimately what will happen, this particular charge will not only move towards r, it will drift as well from that particular two pages back. It will also kind of drift, as you can see. So as soon as as and when it moves towards r, it will also go on drifting, and the drift will actually be depending on how much it is moving towards r. So there is a dependency, and that dependency is there in that differential equation. Okay. I have not gone to the solution of this particular differential equation because it will be involving a bit of a fine tuning, but we can do that as well. Just I kept it at this level stage, and if there is in physics, it is not necessary that you always go ahead and come up with a solution. To form the solution itself is also important. Now, of course, this can be done. Okay, it will be a bit of a complicated kind of integration that you have to do for that. Again, it will involve a sort of a infinite series kind of a thing. So we can solve that. I have not done that, but we can actually go ahead and do that solution also as part of the extension of this particular problem. Okay, and as I am saying that all these problems is of course is based on the standards of IIT Advanced or Olympiad, but when I actually teach these things, I do not restrict there. I go and try to give the impact of what this is going to do. Now, if you see this basically mixture of magnetic field and electric field is used in cyclotrons, which is used for increasing energy of a charged particle. Not only cyclotrons, there is something, another thing is called cyclotron is quite common. There is a modern thing apart from that, which is also used here to increase the energy, which is actually accelerated instead of allowing the particle, because in this case also it's accelerated, the particle will not move with a constant velocity. So cyclotron is mostly dependent on constant velocity, wherein basically the fields are reversed. Okay, and that's how basically it gains energy, and that energy gain of the energy is used of a charged particle, primarily electron or proton, to create a beam. So that's the purpose of cyclotron. And even the older days cathode ray tube that we have seen and TVs that which are based on cathode ray tubes is also based on this mutual electric and magnetic field. This causes an Hall effect, but here it will not cause an Hall effect because it depends on the direction of the magnetic and electric field. And as they are constant, the charges are moving like that. But for example, if your electric field and magnetic field is not constant, they are changes with time, that will that will cause electromagnetic wave also, because each of them will have a induction to another. Okay, so there are all these things which actually makes differences, and basically it's learning from the basic and then using that basic to go beyond and solving different problems. Okay, that's my objective, and that's why actually I'm trying to coach. It is just not restricting onto the syllabus itself or syllabus of, let's say, IIT Advanced and things. Of course that those are important in terms of cracking it, but with the amount of problems and guide that you see, and also the different materials that you get, this may not be, you will get a lot of materials which is kind of aligned to those particular syllabus, but you will not get material which will talk about where it applies on the higher level. So that's what I'm trying to bring in, and that is what is there in my teaching that I'm going to provide, which is offline and online, which I'm saying multiple times. If anyone is interested, can comment into this video. I can let them know my contact details and things like that. And when I say basically online, it's not basically a video online, it's a live online teaching. That's what I do. Okay, video online is not appropriate, I would say, to go into that level. And secondly, I have also mentioned multiple times, I do have a booklet which contains many such problems, okay, and solutions, and all these problems are self-compiled. It's not taken from any book or anywhere. You will get those books, that in any case it's there in market. You will get many books which are aligned to basically IIT Advanced primarily, not many for Olympiad, by the way. So this will not only help for IIT Advanced, it is also help for Olympiad, because Olympiad is slightly higher than, I would say, IIT Advanced in terms of the type of problem they provide in physics. So that's what I learned. Yeah, if you have any points, anything, please do comment into the video and like and do a subscription of this video. Thank you.